In order to build an algorithm for following this line, we must first decide on our strategy and what are the different conditions and the different decisions that the robot must take while following the line. We know that this is the start, so right here we have the start, and the robot moves from the start and must reach the end. Now, first, if the robot moves in this direction, we must decide to go left. So that's the first decision that we must take the robot. Then we have a gap, and for this gap we must decide, okay, we have a gap. That's the second decision. Then we must turn right, and that's the third decision. And then again we have a gap for decision. Then there is a section here that we have the lines crossed, and we must take another decision, 5. Then again we see a gap, 6. Then we just follow a line, and we have a seventh decision, that is to move left. Then we have a gap, 8. Then we must move left, 9. Then we move from this direction, and then we must move left, so it's the 10th decision. Then we must move right, 11. Then again right, 12. We see a gap, 13. We see another gap, 14. We move right, 15. And here on this section we must decide to move left, so it's 16. So it's something like 16 different decisions that we must take while following this line. And now let's try to group these decisions so that we know, are there really 16 decisions, or we have 4 or 5 different decisions at different times that we must take. I will take another sheet of paper, and using this field, let's try to draw the different decisions that we must take. First, again, if the robot is coming from this direction, so the robot is coming from this direction, we must turn left. So the robot is moving in this direction and we must turn left. That's one of the decisions that we take while following the line. Another decision is we move and we find a gap. So that's another decision that we must take. A third decision is to move right. So we move and then we turn right. That's the third kind of a decision. We also have an intersection, which is like this, but the only intersection on the field is we actually move and we turn right. So it's again similar to this previous turning. Another interesting section is we move and we have a line like this. So the robot moves from this direction and then we must turn left. And we also have an interesting intersection where we move and then we must turn right. And then we have again some gaps, and we also have an interesting problem for moving. We come from this side of the section, and then we must decide to move left. And these are 1, 2, 3, 4, 5, 6, 7 different states, 7 different decisions that we must take while following the line. And again, we have a default decision where we are just following a line. So what I would like to do in the next couple of videos is to start from the most simple case, just follow a line, then follow a line and turn left, then follow a line and see a gap, then follow a line and turn right, and move through all the different states. And while moving through all different states, we'll build in an incremental way a robot that follows the line and that can take the correct decision on each step. For this, we'll use very interesting technique while programming, and for this technique we'll separate the logic of our robot on, let me just, okay, the camera should focus. We'll separate the logic of our robot on states and behavior. And if you have the EV3G software, and for EV3G software we can use different variables, but the basic idea that I'll use in this program is the following. First, I'll have part of the program dedicated to finding the state in which our robot should be. Let me just write state. So it's the state of our robot. And the state is one of these 7 different conditions: turning left, finding gap, following line, turning right. So that's the state. And after we find the state, we check the state and we command the motors. So we program the motors, and these here are the motors. And we'll separate our program in these two large parts. First finding the state, and then depending on the state we control the motors. And if we are in one state, we control the motors in a certain way. If we are in another state, we control the motors in another way. And there should be no the only way we communicate between these states should be actually one variable that's called state. Let's start with the very simple program to just follow a line. For following a line, we'll use our EV3 competition robot, and it has a number of sensors. I'll describe them in the next video. But first, for following a line, we use the proportional line following algorithm, which is described in one of the previous videos. So search them at the bar above, or check out the links below the video, so that you get the idea of how do you follow a line with one of the sensors. And it's a proportional line following, and it works like this. Now here it will lose the line, then again we can follow the line. In the next video we'll change the proportional line following program so that we can find the gap and move through the gap.